Hi, my name is Eiko Yoneki. I would like to introduce a project called BUGALERT, which tackles the pest and disease on the crops in the greenhouses in Kenya. In the sub-Saharan region in Africa, farming is a fundamental income source and securing a steady income is important. The climate is biannual, with dry seasons when many farmers suffer due to water shortage, and the rainy seasons when crops sometimes get destroyed. Greenhouse has a permanent glass or plastic-covered structures, and it protects the vegetables, herbs, and the fruits year-round. Smallholder farmers who grow under open irrigation constantly face pests and diseases that cause a staggering 50% loss of their yield on average. Therefore, greenhouses are becoming popular as a way to protect crops from pests and diseases. Farmers can thus reduce crop losses by almost 20%, but further improvements are limited because they have to detect pests and diseases by eyes to take appropriate action. Most pests and diseases are difficult to spot by eyes and may only become apparent once they have fully infested. Farmers also try to diminish or prevent the use of chemicals in order to keep crops organic. In our BUGALERT project, we explore a smart greenhouse monitor solution. We use image recognition to detect the pest and disease infestations and alert the farmers. Project is especially for low-income farmers who can't afford expensive tools. The system uses networked, inexpensive Raspberry Pi computers. We integrate a camera and sensors to each Raspberry Pi to take pictures of crops and obtain environmental data. Raspberry Pis can communicate each other for data transfer. Each Raspberry Pi and the sensors are kept in a transparent plastic case to protect from the weather or any other impact from the environment. The collected data will be aggregated at the gateway node in the greenhouse, where they can be partially analyzed and sent to a server in the cloud via wireless communication. The communication between the gateway and the cloud can be Wi-Fi or 3G, 4G cellular networks. At the server in the cloud, the aggregated data will be further analyzed using advanced techniques such as machine learning-based image recognition. The whole operation will be integrated as a pest disease alert system to proactively communicate with farmers. We collaborate with a small company that uses greenhouses mainly in Kenya, deploying BUGALERT. This is a plot of a web-based dashboard. The farmers can monitor the condition of crops in real time. There are several sensors deployed currently. Those are temperature, soil, humidity, CO2, and also camera. They capture the data continuously. As necessary, you can change the monitoring interval, whatever the required value, such as a minute, 10 minutes, or 1 hour. This screenshot shows a prototype of a platform for analysis. You can select a dataset with a specified duration or type, then run analysis. The analysis can capture the time when the plants got a significant change, such as many aphids on the leaf. Apart from pest and disease detection, the acquired plant images can also be used for advice on the proper feeding patterns to ensure that leaves remain green and healthy. I show you a couple of examples of analysis. The first plot shows the recurrence plot of the plant image, where repeated events on the time series into a two-dimensional representation. Therefore, image descriptors can be used to characterize visual properties so that these features can be used as an input of a classifier. The second one demonstrates use of deep neural networks for classification of images. Either it is healthy or diseased. The model is trained using existing large plant database. The project is still in pilot stage, and we keep working with the greenhouses in Kenya, with which we have established a good collaboration base. However, any other developing countries where greenhouse farming is developed to grow crops such as basil, tomatoes, and capsicums will ultimately benefit from BUGALERT project. With the technology introduced in BUGALERT project, we expect to reduce pest and disease occurrence by up to 50% due to improved early detection. This could also reduce the use of chemicals, allowing for more valuable export products. The project could be widely beneficial for farmers with a substantial economic impact. For farmers to implement the technology, they will need to shift from traditional labor-intensive crop detection methods to efficient modern image technology. I would like to note that our technology has a capacity to serve men and women equally. However, women will be more likely to get the benefit, given that about 86% of Kenyan farmers are women. BUGALERT technology is tailored for the farmers who can't afford expensive, complex technology available only to large-scale farmers. We will build a community based on our technology and the research effort, providing opportunities to extend the project. Thus, we expect a longer-term and broad impact throughout Africa, including applicability beyond the greenhouses. Thank you.